Web scraping is one of the best techniques that you can use to make your AI smarter. However, what a lot of existing guides get wrong is that they assume that you need all of the data that you've scraped. This is not the case. In fact, a lot of the times, this extra context might make the AI more confused rather than help it to answer questions better. So in this guide, I'm going to teach you some secrets as to how you can actually scrape the web in a structured way to turn raw internet data into golden data that you can use to make any AI smarter. Let's get into it. So on my screen on the left, we can see the Wikipedia article for the United Kingdom. And here on the right, we can see Firecrawl, which is a great tool that you can use to crawl the internet, but then also turn those scraped web pages into structured data for your AI. To show why it's not a good idea to naively scrape the web, I'm going to first paste the link to this Wikipedia article into Firecrawl and just do a regular web scraping call. This is going to return the content of that entire Wikipedia article into a markdown file format. And you can see that it's already done. And the markdown file has a bunch of data. It's a huge article with a bunch of links, of course. And what we can simply do now is copy this markdown. And I'm going to try to use Claude, a very popular AI chat app, to ask questions about this country and see how well it handles it. On the Claude homepage, I can simply paste this markdown, and you can actually see that right now I'm 11% over the length limit of their model. So I haven't even asked a single question, and I cannot even start a conversation. This shows you that it's a bad idea to naively scrape the entire web because you might just add way too much context to the AI model. Now, some of you who are more familiar with AI development might say, well, why don't we store all of these websites into a database and then extract only the most important information based on the user's question? And you can indeed do this, but I put it to you that it's also very important to not scrape information that you do not need at all. So I'm going to show you how you can extract structured data from these Wikipedia pages to make sure that you don't scrape way more data than you actually need. In Firecrawl, we can make use of their new extract functionality. And I'm going to manually enter again that Wikipedia page URL. And now I can define a schema. This schema is going to be a data object that I'm requesting Firecrawl to return to me. And this data object will be a structured set of information that I can then parse with a programming language like Python, or that I can paste into an AI model to ask questions about it. So we can start with something very simple to illustrate this. I can start with the country name, which is a string, perhaps just the dominant language, which is also a string. But you don't just have to rely on strings, so text types. You can also go for a number, a Boolean, so that's a yes or a no, an object, so a more complex object, or an array, which is going to be a list of items, of course. So to challenge this system, how about we try something more complex? If I scroll down in the Wikipedia article, then I can see that we have got this population section here. And this is not just one number because Wikipedia often has estimates and a census number. So the population in this case is actually going to be an object, and I'll show you why. I'm going to just type out population and make it a type object. And then I'm going to have both the estimate number type in here, as well as the census number type. That's not all. I think I also want to have the years of the estimate and the census because this might differ from Wikipedia page to Wikipedia page. So I'm going to then also have the estimate year, which is going to be a string. Well, no, I think it can be a number because it's a year. And I'm going to have the census year, which is also going to be a number. Now, it's also important to think about which data is going to be mandatory. I'm only going to make the country name mandatory because, well, I'm expecting the country name to be in every Wikipedia page, of course. So what we're going to do now is we're going to run this extract method and see how well Firecrawl does its job. Once I click on the run button, you can see that it's starting to scrape the URL, but then it does more. It extracts the information from the page, which can take a little bit of time. But if we are patient enough, then we will see the data object show up very quickly. And there we go. So you can indeed see that we have the country name, we've got the dominant language, and we've got that population object filled in. Let's double check if it's actually correct. So we've got that census number, which, yeah, looks to be correct. Then we've got the estimates, which also looks to be correct. And then we have the census year, 2021, and the estimate year, 2023. Very nice. Now, what's important here is that you can also define your prompt. So if you need to give more explanation for how a given data type should be found in the article or should be structured, then you can put that inside of your prompt. It wasn't necessary for this use case, but you might find that as you try more complicated use cases, you might need to provide those details in the prompt. What we're going to do now is we're going to see whether this actually works on multiple Wikipedia articles. So I'm going to go ahead and probably just go and find the United States Wikipedia article, and then I'm going to add that to my list of URLs. Now, it's important to note that this is not actually going to give me the result that I want. The reason for that is because I'm defining one schema for the entire output based on all these URLs. The problem is with my current schema that we only have space for one country. We've got one country name, one dominant language, etc. So what we actually need to do is change our schema. The way we need to change our schema is by adding a countries array, because we want to get information on multiple countries. And then this is going to contain an object with the fields that we've defined so far. So of course, I want to have the country name in here as well. Instead of just manually copy pasting what we've done so far, I can also just go into the JSON view and do it in a bit of a smarter way. This is kind of like the code view for our schema. So the way that we can use this JSON view is to copy paste more complex objects, because you will find that the UI is a little bit lacking. For example, I can try to move this population object by minimizing it and trying to drag it inside this array, but it just doesn't really work that well. So sometimes you will need to edit the JSON in the actual code view. I'm going to quickly copy over the easy parameters though, because this is going to take no time at all. Dominant language, I can just easily reformulate it like so. Then I'm going to make the country name required again. I'm going to remove it from here. And then now all that's left is that we have to use the code view to move this complex population object inside of here. So inside of the JSON view, you will be able to see that we've got that property in here. So I'm going to go ahead and copy everything up to this point. And then you want to remove it from the definition as such. I'm going to remove this empty line as well. And now what we want to do is we want to add a new property to the items of this countries array. So I'm going to go and add a comma here because we're adding a new property. Then I'm going to press enter, and I'm going to go ahead and paste what I just copied before. And most importantly, I have to get rid of this trailing comma because there's no other property yet. This is going to close off the object. So I'm going to get rid of that comma. And now if I go back to the JSON view, you will see that I have a countries array with the country name, dominant language, population, object with everything that we need. So we got that estimate again, the census, the estimate year, the census year, and that's it. Now, because we have this countries array, if we run the Firecrawl extractor on these multiple URLs, it will understand that it needs to provide the structured data for both of them. Let's go ahead and test that. We're going to simply click run, wait for a couple of seconds, and then see how it did. So you can actually see that it didn't really extract what we wanted, but that's actually okay. As I said before, sometimes you need to use the prompt to actually specify how the schema should be filled. So let's do that. For each Wikipedia country page, fill in the details of each country inside of the countries array. Let's try that. And this will be a great example to show how that prompt can actually help Firecrawl to properly put the data into the object. Great, there you go. So you can see how easy it is to kind of change things and make it work better for your use case. Now we actually get two country items. First of all, we get United Kingdom, and then second of all, we get United States. Let's quickly check whether the information of United States is actually accurate. So on the Wikipedia page, we're just going to go ahead and check out the population estimate. So indeed, for the US, the estimate year was 2024, and the census year was indeed 2020, just like you see in here. And then if we just quickly check the estimate numbers, I can see that that's completely correct. And the census numbers are correct as well. So that's great. You can see here how it worked completely. And now to show you that it's much easier for AI applications to handle this kind of data, I'm going to copy the JSON and start a new chat with Claude. Remember at the beginning of the video that we tried to have a conversation with the entire Wikipedia page of the United Kingdom, and that didn't work at all. Well, now I can simply paste the object and say something like, shortly describe the countries provided in this list only with the provided details. And then you will see that Claude will generate a response based on that data that we generated, which is structured in such a way that the AI will pretty much always give you a very useful response back. Because here you can see that the model is aware that we have information on both the United Kingdom as well as the United States, together with the population numbers, which are based on the estimates as well as the census. So this all shows you that it's important to think about what data your AI actually needs. And if you want to learn more like this, I've got a completely free 1.5-hour AI development course that you can access completely for free by checking out my school community in the description below. There's a lot of members that are going through this course right now, so I hope to see you there and answer any questions you have.